Whoa, sorry. All right, so there's the question. I believe the multiple choice answers are 0, 1, 2, 3. So you can't see the bottom, but there's the question. And Isaiah's not moving. What's the answer, friend?
1.
He says 1. And those of you who are struggling to see, there are seats closer to the front. Welcome, people who are late.
I'm really sorry.
Yep.
I'm not. I met someone who was British when I walked here.
You are so random. All right, so here we have a graph of, and it's got 3 line segments. If G is the antiderivative, Roisin, what the hell does that mean? G is the antiderivative of X. Okay. Oh, it's not going. Why does it not move? It does not want to move. Okay. So G is the antiderivative. Antiderivative means integral of F. Isaiah says, how many values of C were there from 0 to 6 such that G of C equals 3? This is F. Is F of X equal to G of X? So what are you still going with 1? Or are you just saying, oh, this graph here crossed 3 once? Because that graph is of F, not G. Noah, what do you see?
Well, this is G of X equal F prime of X.
Yeah.
Well, let's check. The function G is the antiderivative, so it's the integral of F. So G prime equals F.
Oh, yeah.
Right?
Actually, I don't even know what I was saying. Never mind.
Natalie, what were you going to say?
That.
Okay.
My brain.
But how do I find out what G equals? Mario? Okay. How?
So G of C is equal to
They gave us this information too. G of 2 equals 5.
Oh, the integral, and then so we do that. So if you write f of x is equal to the integral from like where from C at the top to the bottom. Am I doing
So no. So I'm telling. The problem gave you one anchor point. When x is 2.
Oh, there's a formula for this.
Oh. Can we see the question?
It's down there. The graph of function f shown above consists of 3 line segments. If the function g is an antiderivative of f, such that g of 2 equals 5,
Okay.
for how many values of c?
Like this is an important point.
G of
So
2.
the integral is how much stuff has accumulated since a certain point in time. They only gave me one piece of information, one piece of information about a point in time that G of 2 was 5. Somebody was there, they took a picture, 5. So f of x is how much was accumulated since 2. So going forward, how do I evaluate, Carson, how do I evaluate this integral thing?
Well, there can
It's visually the area under the curve, right?
Wait, but
You don't
can't
understand
we
what?
just
Hold
look
on,
at?
hold on. What?
I just don't understand the problem.
Okay. Make all those other words go away. I know those are the words, I know. Carson, if this is f of x, would you know what to do with that?
G of x.
I think so.
What do I do? Area under the curve. That's what integral is. So what is the area from 0 to 2? Well, it's the area of that triangle, and area formula for triangle is half base times, base, which is 2, times height, which is 2. So the integral from 0 to 2 of f is just 2. Okay? Okay, follow me there. Good. So, here's all the words again, okay? So, when we integrated 2, that's 2x plus c. It's any straight line that had a slope of 2. And the only difference between them was a vertical shift. I don't know what this guy's vertical shift is until I read the words that we uncovered. It didn't tell me when g of 0, what g of 0 is, so I don't know its y-intercept, but I do have some information where it's anchored down. So this one is anchored down. I don't know 0, but I know g of 2, and the integral is how much did the function change from this point in time? So they asked us, when is g of c equal to 3? Isaiah?
I'm like kind of confused because if g is the integral of f, how can it be 5 of 2 if 0 to 2 f 2?
Okay. Okay. Let's say this is a change in stock price over time. And this is where we are right now. And my stock price is worth G of 2. My stock price is worth 5. If I went backwards in time, did my stock price go up or down?
Up.
I heard both answers. I heard up and I heard a down. I can go back in time. Trust me. Like to go back in time where my stock price was worth something. So if this was your stock price at time 0, because I'm now at time 2, recession, depression, whatever you want to call it, has happened. This is what's happening to my stock price. Did my stock price gain value from 0 to 2, or did it lose value from 0 to 2? Lost value. So if I was 5 here, I would have been okay. Not doing this well. Okay. Integrating from area-wise 2 to here. You okay?
Yeah.
All right. Integrating from 2 to 0. Carson did 0 to 2 a minute ago. Integrating from 0 to 2 was positive 2. What is integrating from 2 to 0 though? Negative 2. Because the dx was negative, the y value was positive, so overall, like the area back there is negative 2. So just hold on a second. And this value that they told us was 5. 5 plus negative 2. G of 0 is going to equal 3. What were we going to say, Carson?
How did you, what's written in the blue up there, how did you get that from the problem?
They told me one piece of information about G.
Yeah.
Other than the integral of f is G. And one coordinate they told me, G of 2 is 5. So from G of 2, the integral is how much did G change? So I'm going to integrate, and I need to anchor it down to the one coordinate they gave me. So how did it change from the one point they told me? Well, moving forward, stock price is still dropping. And it's still dropping. So it was at a woot high point of 5 here. And then it dropped another 2 by 2 divided by 2. It's going to hit 3 here as well. So let's see. The AP exam, the way they write their answers is not the best. So they are telling you that. And what is their end answer at? C equals 0 and C equals 4, and that's it. So there are 2 places that it's equal to 3. Yeah, all right.
Why is this two
The third solution is C equals 5.5. Isn't that off this? Oh, at 5.5. Okay.
I didn't know.
But you didn't math this? Okay. All right. So the idea of integration being the area under the curve, and let's think about this graph as velocity. If it's velocity, where are your maximums in your position? Where do they occur? Kiana?
When it goes over 0 from positive
Okay, no pronouns. What is it?
to the normal graph. Or the derivative graph.
When the graph of the derivative
Yeah.
crosses the x-axis and goes from positive to negative, this is going to be a maximum. What is this one? A minimum, because when it stops, when your stock price stops tanking and starts to rebound and improve, this is, the derivative is slope. The slope was negative, it was losing value, and then it started gaining value finally, and started to bounce back a bit. So I need you guys to be able to read that kind of thing from these graphs. We're going to do these on Monday. Working more with, all right, I'm going to tell you g of x is the integral of f of x, and where are inflection points on g? Other Asher, that Asher.
Yeah.
Where would an inflection point on g be, and how do I read that?
It would be when the slope of the derivative graph changes.
Yes, it would. When you do these problems that are free response questions, and these are called fundamental theorem of calculus, the word fundamental, there will definitely be one full free response question on the fundamental theorem of calculus. One of the points in these answers is always, how does G connect to F? Because if you start telling me, well, G's doing this, but I gave you a picture of F. What's their relationship? Are they grandparents? Are they siblings? Are they sisters? What are they? Well, that's not helpful. The derivative of G equals F. And what Asher just said was inflection points happen when the second derivative changes sign. How do I read F prime off of F? Morgan, how do I read F prime from F? What does the word derivative mean?
Just the slope.
Is slope of F. And then Asher also said, for an inflection point to be an inflection point, the second derivative is 0 or defined, but must also change sign. And the only place the graph of F changes value of the slope is at 4. So you need to be able to read through those things. Questions?
Wait, does it also change slope of 5?
Okay, the slope, did it change sign? The slope. Was this a positive slope? And then there's a kink in the problem,
Yeah.
and there's still a positive slope.
Oh, well,
So first derivative, f, the particle or whatever it was moving along, moving down, and then it hit there, and now it's moving up, but technically the slope of this line is still positive all the way through. There's a wrinkle in it, I agree with you, but it did not change sign. You don't like that answer? Okay, sorry. So moving on to the excitingness of today. Well, larger than life.
Indeterminate form.
The
Infinity
worksheet
minus infinity.
from yesterday, the answer key is posted, and there's definitely some spaces that were very cramped. I apologize. It's just one.
What I was watching on TikTok.
Since the rule applies,
You good, sir?
All right, we need a reminder of L'Hopital's rules. Logan, what are the conditions that make L'Hopital's apply?
If it equals 0 over 0, or 0 over 2.
Okay, when 1 equals 0 or 0. A derivative, a rational function. So, Eric, what's the other condition that L'Hopital's could apply?
Well, you've got 0 divided by 0 and infinity divided by infinity.
Do they both have to be positive infinity?
No, they do not.
Could they be a mix and match?
Just again.
So positive infinity over negative infinity is okay?
Yeah, that sounds right.
Yeah, cool. All right, awesome. So then what's the conclusion? Okay, then L'Hopital's rule applies. So apply L'Hopital's rule. What does that mean?
I take the derivative of x and g of x.
So it means we can do the derivative of the top and the derivative of the bottom, and if that gives me a value, woohoo! I've evaluated the limit. I am not inventing a new way to do derivatives. This is not a new quotient rule, because I didn't ask you to do the derivative. I asked you to find the limit. Said to myself. Do you guys remember this? Sine x over x, as x goes to 0, what's the value? 1. It is 1. And that's one that I asked you guys to memorize at the beginning of the year and was like, well, I'll get to it later and I'll show you why. So L'Hopital's 0 on the top, 0 on the bottom. Hey, it applies. So, key, do the derivative of the top and the bottom. What do I get? Derivative of sine, cosine, derivative of x, 1. Amalia, what is cosine of 0? 1, and 1 over 1 is 1. So we get the answer that Carson said earlier. Awesome, pre-calc people going crazy. Okay, so these problems are a challenge. Oh, Miss Frager, stop. Alright. Something weird about this doesn't look right.
No, it doesn't.
What's wrong? Ashley, what were you gonna say?
Oh, no, I'm not even looking at that one.
You were doing this, so,
Just tell me to stop talking.
okay, stop talking.
I think I was.
Oh, whoa.
He said, tell me to stop talking, so I did. Yeah.
Is it that, is it that, okay, well, does one of those equal infinity?
Okay,
Is one infinity larger than the other?
okay. So, guys, here, let's look at what's going on. What does the graph of natural log of x look like? Okay, you guys are doing the swoop. That's natural log of x. As we get closer and closer to 1 from the right, natural log of x is getting closer to 0. So it's 1 over 1/10, 1 over 100th, 1 over 1,000th. What is
Infinitely
1?
small.
What?
Infinitely small.
Infinity larger.
The other way. 1 over 1/10,
Okay.
1 over 100th.
I was thinking just the denominator.
Right. The denominator's getting.
Infinitely big, the whole thing.
Okay, so the denominator's getting itty bitty teeny tiny, which means the
Oh,
reciprocal
wait, so
of it.
it hits at 1?
So this is becoming infinity, which is what my L said. And then this one,
That's
1 from the right, minus 1, it is also becoming like 1.1 minus 1 is 1/10, 1.01 minus 1 is 100th under here. So it is also getting bigger. So this is infinity minus infinity. Does that meet our L'Hopital's rules? No. All right. So it is not 0. Infinities can have different sizes. Hi. Welcome to my class. And just remember, you signed up for this. Yes.
If you made it one fraction,
Ooh, great idea.
then when I got to determine whether it was indeterminate, I did get indeterminate.
Okay, well, we will see. Okay, so Carmen has a great idea. She's like, you know what? This limits thing, this L'Hopital's rule thing, we need a single fraction. So common denominator, find that single fraction. And because the AP exam is a pain in the butt, yes, we need to go through and verify the numerator. Plugging in 1. 1 minus 1 is 0. What is natural log of 1? 0. So 1 minus 1 is 0. Minus natural log of 1 is 0. Okay, that is 0. Jackson, the other one, when I plug in natural log of x times x minus 1, what is that? Is also 0. So Noah, does L'Hopital's apply? Yes, it does. All right. Indy, what is the application of L'Hopital's to the numerator?
1 minus 1.
Derivative of?
Over x.
Okay.
Oh, come on.
Oh, come on. Again, you signed up for this. Yeah. Lanham, how do I do the product rule to that nasty looking thing in the denominator?
So it's the first one times the derivative of the second, so ln(x) times 1.
Do y'all mind if I just don't put the 1? Sorry, Eric, I'm not going to put the 1. And I'm even going to erase the parentheses because that's just going to confuse me. They're going to get in my way. All right, so first times the derivative, second. All right, now the rest.
Then it's the second times the derivative of the third, so x minus 1 times 1 over x.
Oops. So second times the derivative of natural log, which is 1 over x. Okay. So now I can just plug in 1. Iris, when I plug in 1 up top, what do I get? Oh, bummer. This is not looking good. Oh, yeah. Not again. Morgan, when I plug 1 into the bottom, do I get a number? Because if I do, Yahoo! I still get 0. Natural log of 1, and then 1 minus 1 over. Suggestions?
Do it again.
Yay! This is so much fun. We get to do it twice. Is it gonna work? Miles like my patience is running thin.
It's just like it's gonna explain that forever.
Alright, we do have problems in we don't do this one thing, but I call it chase your own tail problems in basic calculus. They're like, I love those. Sam, what do you think?
I was just gonna say, I feel like on the sheet that we got yesterday, there was one where you had to do it twice, and I was
Yeah.
like, do you do it twice? Because I didn't.
Yeah. Number 8, and there's like no space. Number 8, I think.
Tangent x over x, I think it was.
Okay. There's one of them you had to do like 3 times, and it didn't fit. My answer key is a mess. I just tried to write tiny. All right. The numerator. Sam, what's the derivative of the numerator? It's tricky.
Is it? Oh, it's negative 1 over x squared.
Okay. So the derivative of 1
Nothing.
goes away. It's 0. All right. The derivative of the second piece multiplied by the power. What is the power on that x?
Negative 1.
So negative 1 times that. Oops.
Oh,
becomes
the
positive.
negative goes away.
And now lower the power. Okay? All right. I'm going to rewrite this one just so that we can do the derivative of the denominator more easily.
So,
Are you guys okay that I split x minus 1 over x to x over x minus 1 over x and reduce the x over x to 1?
Yeah.
Yeah.
wait.
This, it becomes x over x minus 1 over x
So that just becomes 1 minus.
1 over x. Good?
How excited.
Okay. Well, the derivative of natural log of x, the derivative of 1, and the derivative of negative 1 over x. Sam already did it, so it's
1 over x squared.
oh goodness. Jackson, can I finally plug in 1 and get numbers? One over 1 squared, or is 1? Oh, that's a number. It's not a 0. Yeah. I'm guess. 1 over 1 plus 1 over 1 squared. So 1 plus 1 is. So infinity minus infinity today is 1/2. How far apart are they? They get to walk hand in hand off into the sunset together, 1/2 apart.
What is that?
They're in superposition.
Oh, they're just 1/2.
They're friends. They're holding hands. They don't want to be on top of each other. They need a little space. Isaiah?
What would the graph of this look like?
Oh hell, I don't know.
No.
Yeah, you can put it in some Desmos and go check that stuff out. I don't know.
Eric, how do you feel knowing that infinity is actually
Yeah.
in superposition? And so you do this?
How does this specific thing apply in real life? There are problems when you need to do limits of stuff where stuff
I think we're
doesn't.
infinity. I think about infinity a little too hard. Maybe infinity was something that we created
Hold
so
on.
we could characterize.
I told you,
the
like,
never
please
ending.
get quiet,
We're like,
speed
let's
it
make
down.
it like that's
So that's a, okay.
infinity is not real.
Wait, so what does 1/2 actually mean here?
That is the value of this limit, period.
Miss Pascal.
And it's a fun theoretical problem. Okay. Guys,
Fun theoretical.
hold on.
You can see it in the graph. As x approaches 1, as x is approaching
This
1,
is infinity minus infinity, which, 5 minus 5 is 0, just 0. But infinity is this slippery concept of not a specific number. It's a concept of it goes on forever. You're going to ask.
So do you keep going from like the derivatives until you get a number?
Okay, good question. Doing L'Hopital's rule. Do you keep going?
If it keeps flying.
there's a really small hole in the graph at 1.
Yeah.
Because 1 is undefined, but it's approaching 1/2 from both sides.
So this thing, plugging in 0 up top, I get 0. Plugging in 0 on the bottom, I get 1. Do I do L'Hopital's? No, because L'Hopital's doesn't apply. What is this value?
0.
0. I have nothing, but I will share it with all of you equally, with love. Still means y'all get nothing, but it's with love. Yes, ma'am.
So what is this if it's from the left?
Okay, from the left,
It is also
it would be negative infinities on both of them. So it's negative infinity minus negative infinity. So it's still infinity minus
So it's
infinity.
just, but they never quite.
Right.
This is what it looks like.
Also, why do we spend so much time trying to undo infinity if we like made up infinity? Like infinity doesn't really exist; it's just made up. Why are we spending all this time trying to undo it?
Okay,
Does infinity exist?
hold on.
So it doesn't.
People, y'all gotta stop asking questions that I can answer.
Infinity doesn't exist.
You don't, but all right.
Name one.
You will be
Infinite
dead and
thing.
gone before it comes. I agree with you. However, examples of what? Okay. All right. So,
What in the
climate change is a problem.
Yes.
I have an equation that I can model the impact of climate change by car emissions that are not up to code. If I integrate that problem from now to infinity, you will see the equation.
Yeah, but
like,
that's made up.
okay.
But
no,
the world will
okay.
eventually end.
All right,
so.
depending on your politics, maybe it is. But scientists with data and facts will tell you we've modeled this and this and this and these 18 million other things of the impact of acid rain and carbon emissions and CF4s and like all these things. We've modeled them, and is the problem of climate change containable? And
But how are you
very,
gonna model
very
it to
importantly,
like
the answer is
infinity?
no, it's not. How do we know it goes on infinity?
Yeah, like what I was saying doesn't exist is the infinity of it. Like
The world will just.
and
The
there's a
infinity
finite
is the world.
amount of
So-
time.
So
There's a
not to
finite
be all
amount
like
of time.
alarmists, but if y'all don't change some attitudes and behaviors, y'all just screwed.
I mean, it's
No,
going
I'm-
to infinity, but the
We're not
infinity
talking about
doesn't.
climate
It does
change.
end somewhere. It does end when like the sun explodes.
Okay,
and the
then
world
I'm the
stops
babysitter
existing.
from hell because kids would be like, I'm bored, I want something to do. Count to infinity, and they'd be coming in like, I'm done. I'm like, add one, go away.
It was
Yeah.
totally
That's
made
what
up. It doesn't
infinity
exist in the
is.
physical
Ah,
world.
exists.
Shush.
So
Okay,
we made it.
stop.
Everything's
Enough.
got to be finite.
This
Segue
makes my head
done.
hurt.
Yes.
Wait, can you go back to the thing?
Oh, seriously? I wanted to do like, I want to move on.
Like back.
Well,
Like back again. I erased it.
But never mind.
It's gone. I'm sorry.
But the like, if it's like to one from the left, what do you do?
Okay. The reason that we have those from the left and the right things, natural log of 0 cannot do it. Do I know where it's approaching when I come at 0 from the right? That I can do.
Why wouldn't it? Because the function just isn't defined over there.
So
Like a square root.
natural log, natural log of something negative cannot do that number. So this is the graph of natural log. It's e to the x reflected. 0 from the right, that's going to negative infinity.
This is yesterday's slide.
And if it's just as it goes to 0, you'd be like, shoot, I don't know.
I was.
Miles saying this is yesterday's slides. I didn't post today's yet. I'm sorry. Oh, it's the second part of the same slideshow. I did post it. Go me.
But like, if it,
Cover anything, so.
Okay. Oh, is this covered up on there?
Yeah.
All right. So this is not in notes. This is not on that sheet. But you need to know a strategy. We don't teach you this anywhere. It's sort of in the pre-cal curriculum, but we don't tell you. Believe it or not, you all know the answer to this. You don't know it yet, but you do know the answer to this. So, guys, question. Does the limit affect sign? Like, does the sign, no, it doesn't. So, can I pick this up and like squish it inside sign?
Yeah.
Could I squish it inside the square root also? Like, did I hit X yet? I did not hit X yet, so I can keep moving the limit inside because that is so. So, because sign didn't have X on it yet, so I'm going to move the limit in. The square root doesn't have X on it yet, so I'm going to move that in as well.
Just doing things because we can.
Yes, yes. I get away with all kinds of things. Okay.
Just move it inside.
But now look at this. Remember pre-cal.
Oh, yeah.
Oh, for the love of God, please remember pre-cal. The limit as x goes to infinity of this crazy looking rational function. It's 0. Why is it 0, Natalie?
Because the is bottom heavy.
Bottom heavy. So there's x to the 5th on the bottom and x to the 3rd up top. So it's 1 over huge. So this goes to 0. Okay, so that's sine of the square root of 0. So Carson, what is the square root of 0? What times itself is 0? Yes, 0. You sounded like you were on Jeopardy.
It's like,
Well,
I was
Alex,
saying
I'm gonna
Jeopardy
go
question.
with
That's what it was. That's exactly what I was thinking.
And then what is sine of 0?
Big number.
0. So what is this limit? 0. So we can push that limit in or out however it suits us as long as you don't cross over the variable. If you're kicking one of the variables out, you've gone too far. All right. Y'all are gonna hate this next thing. I'm just not gonna lie. Not gonna lie. It's okay.
You were gonna hate it so much you didn't even show it to us.
Yeah, okay, I'm not gonna show you all that. But that yesterday, is this the next problem that's on that sheet?
Maybe.
You don't have that.
We have x to the x,
Okay,
but it's to 0.
well, on separate paper then, this is the one I talked to you guys about yesterday. This is a definition. This is a mathematical definition of a thing.
E.
Oh, yeah.
I don't remember
So-
this.
If I plug in infinity, 1 over infinity is basically 0. So this is 1 to the infinity, and 1 times 1 times 1 times 1 times 1 should be 1, but these are sufficiently large enough values of 1 that multiplying them together, you will eventually get E, which is 2.7 and jump. Yes, sir.
I was about to say, like, how did you go from 1 to 2?
Okay, I'm gonna show you. Oh my goodness. That'll be so fun.
Okay, Miss Pascal, but if 1 to infinity, right?
Oh, shush.
Just 1 to
Just stop.
infinity.
Just
That's
stop.
gotta be 1, right?
I'm going with no. All right,
Because that's not
Just-
quite 1.
Eric.
Shit's 1 plus.
That's funky.
What's the function that undoes E? ln. So if I have E of ln of x, that's like multiply by 2 and divide by 2. Don't you get x back out?
Yes.
So if I do E and ln, they undo each other and I get the thing back out. All right. So this is a strategy in calculus that we are going to use. We are going to do E to the ln of this big yuckiness. And Isaiah goes, sure we are. Okay, and then I'm going to do that thing and I'm going to pull the limit out.
But only outside of ln.
Yep.
Why?
Why?
You said we're having like an exit card every Friday.
Tomorrow, yeah, we're gonna have a free response question thing. It's not an exit card like you would imagine an exit card.
So
Tomorrow's a freebie.
on what? That?
No. You will see tomorrow. Okay. So E and ln, the reason we do this thing in here, this 1 plus 1 over x, the value is changing as x changes. So is the exponent. The only way I can make that thing go away, like I can't do the derivative of this. However, I know laws of logs. What can I do with that little exponent thing that's on the argument inside? It can come down up front. So this becomes x times this. Okay, that's cool. I like that. Carson, it gets better. Yeah, theoretical math. Here it goes. Does L'Hopital's apply to this limit?
Wait. Okay, that's what we did. Yeah.
Does L'Hopital's apply? Do I even have a fraction? No. Okay.
You can make it a fraction.
We can make it into a fraction, as a matter of fact, we're going to. This is why I was like, yeah, Carson, it gets better. He's not sharing the love here. He's like,
this is all E2.
I love fractions.
stay away from me at this.
What?
Oh.
What?
Take it back.
Okay.
Oh, wait.
Okay, I'm trying. I gotta make a fraction. I gotta force some 0 over 0 or some infinity over infinity. Yeah. Okay, Lanham. Now if I do 1 over x times that x, what happens? It's just 1. So I'm left with natural log of, natural log of 1 plus 1 over x.
What did we get?
And in the bottom, well, there was nothing written here. In the bottom, I've got the 1 over x. Yeah. No growling.
Can you explain the
No.
1 over x times over 1 over x? Where we got that from?
Because it just equals 1.
That just was a idea from my brain because I needed to force L'Hopital's to work. I cannot evaluate this limit. I have no idea what it's going to be. It's infinity times 0.
Okay, so where did the 1 over x canceled out with the x?
Actually, it's infinity times. Okay, so just to be official, the limit as x goes to infinity, natural log of 1 plus 1 over x. That's natural log of 1. Natural log of 1 is 0. Looking at the bottom, the limit as x goes to infinity. 1 pizza divided by the whole world. Y'all ain't getting no pizza. L'Hopital's applies. Woot. Asher, how you doing? You're squishing your nose up into your head. No, we don't gotta do. It's not on your paper. Asher, you were going to need this strategy. Yes. Yeah.
How did you go from that red stuff to the blue stuff?
How did I go from that red stuff to the blue stuff?
It's raised to the power of x.
I just multiplied by 1.
No, it's raised
This
to
red
the
to this red.
I'm talking about when it was raised to the power of x.
So the x comes out front because that's a natural log thing. Hey guys, hold on. Wait. Bell did not ring. I'm going to do the derivative of the top. 1 over that stuff times the derivative of that guy over the derivative of this guy. Those cancel. Now plugging in infinity, this becomes e to the limit as x goes to infinity. 1 over 1 plus 1 over x. 1 over infinity is 0, so that becomes, this limit evaluates to 1, so this whole thing comes out to e to the first. So Eric, the limit as x goes to infinity of 1 plus 1 over x to the x, that's 1 to the infinity, 1 times 1 times 1 times 1 for sufficiently large enough values of 1 is e. Oh yeah.
What is sufficiently large enough value?
Sorry, hold on.
How did you simplify the x exponent?
This doesn't stroke my
The
ego.
only result of this class is that I found mine. I don't know what that is, but I found mine.
That's pretty good. That's pretty good. Did you hear some stroke? That is another Schrodinger's racism.
I've had that in the brain like since the quarter started, so.
Yes, yeah.
I'm not gonna do it tomorrow.
We'll make sure to tell
Now I
Dan.
go sit in the road